Hello, this is STA2023, Statistical Methods, Chapter 7, Section 4, Part 2. We're just going to do a couple more examples. This one says, a mortgage is underwater if the amount owed is greater than the value of the property that is mortgaged. For a 2010 Rasmussen poll, investigators interviewed a random sample of 710 homeowners in the United States and found that 35% had mortgages that were underwater. Find an approximate 99% confidence interval for the percentage of all homeowners in the United States that had mortgages that were underwater. So again, to make sure we understand the concept, we're looking for a 99% confidence interval. We're given p hat, which is 35%, which comes from 249 divided by 710. 710 is the sample size. We're going to find our SC, which is square root of p hat, because p is not given. 0.35 times 1 minus 0.35 over 710. That's going to equal 0.018. The formula is p hat plus or minus z star times your SE. So we're going to do p hat minus z star. Now 2.58 comes from 99% confidence interval. We, in the previous video, talked about how to find that z star. You can also do it by hand or it's on the table. So it's 0.35 minus 2.58 times 0.018 and 0.35 plus 2.58 times 0.018. You get 0.34, 0.396. So we're 99% confident the proportion of homeowners whose mortgage is underwater is between 30.4% and 39.6%. Keeping in mind, the point of this is we're given p hat and we're trying to estimate p at a certain confidence interval, so I'm 98% confident that p is somewhere between 30.4% and 39.6%. Now, there's another example, but this example is a little weird, and the reason why it's a little weird is because the whole point of this one is that you're given p hat to estimate p, but in this case, you're given p. You're given p. So I'm going to go ahead and go over it, but this is not my favorite example, so I'll warn you ahead of time. Okay? So Samuel Morse, the inventor of Morse code, claimed that the most used letter in the English language was E, and the proportion was 12%. We took a simple random sample with replacement from a modern-day book. Our sample consisted of 876 letters, and we found that 118 E's were E's. So the p hat is 0.1347. So find a 95% confidence interval for the percentage of all letters in the English language that were E. Now, please remember, in these examples, we normally don't have P. We're using p hat to estimate P. So this is a weird one, okay? So P is 0.12, p hat is 0.1347, N is 876, and we're looking for 95% confident. Now again, the reason why it's not my favorite problem, it's a little confusing, is, well, when I find my SE, which one do I use, P or p hat? Remember, given the choice between p or p hat, p is everybody and it's always better. So for this problem, I'll use p. So the square root of 0.12 times 1 minus 0.12 divided by 876, which gives you 0.011. But again, weird. Normally we're not given p in these type of problems. So we use our formula, p hat plus or minus z star times SE. P hat 0.1347 plus or minus z star is 1.96 because of the 95%, or you could use 2, times 0.011, our SE, 1 minus, 1 plus, we get between 0.1127 and 0.1567, so we're 95% confident the proportion of E's is between 11.27% and 15.67%. Now again, it's a little bit of a weird problem, but something we can do with this problem is that we know that p is 12, and we can say, does 12% fall inside this interval? And yes, it does. So again, not my favorite problem because it's a little confusing because I'm telling you to estimate p given p hat, and this one gives you both. But that does give you another example. Thank you.